Hi, I'm Adam van Niekerk. I'm a PhD student in biomedical engineering. I'm working with MRI scanners and I'm trying to correct for motion.
Hi, my name is Samuel Ginsberg. I work for UCT's electrical engineering department, and my recent invention is a part of the Limkani shack fire detection system, which is an early warning system for detecting shack fires.
Well, my name is Sudesh Sivarasu. I'm a biomedical engineer. I work as a senior lecturer in biomedical engineering at Faculty of Health Sciences. And my latest invention is on patellar surgery assist device.
My name is Chit Swan. I'm a mechanical engineer, and my invention was basically a pressure vessel that we used in a water rocket, which set a new world record.
I'm Kevin Naidu, and I am a person that works in scientific computing. And through a series of big data analytics, we discovered a classifier for cancer.
All surgical equipments are imported, and I really wanted to break this crux of importing devices, and we want to make locally designed and manufactured devices. And at the same time, we also wanted to look at probably a disposable device.
Cancer is an illness that affects 1 in 3 of us. Every 1 in 3 persons on this planet will get cancer, and every 1 in 5 of us will die of it. So, and this outstrips any other disease, anything like HIV or TB or anything like that combined. It's the biggest killer.
My supervisor had proposed a different project for me, and she asked me to do a literature review. And in doing the literature review, I just noticed that a lot of people claimed real-time motion correction in the MRI scanner, but they were actually updating the position really, really slowly. And I just identified that it could actually be done in a much easier way. And I kept just writing about the wrong stuff, and finally she was just like, Adam, you can do what you want, even though it's a little bit high risk, but it might work.
The thing driving our innovation was purely just you know, what was available to us and the costs involved with it. So it drove us to find simpler and simpler solutions to the same problem, and eventually ending up in our pressure vessel, which actually works amazingly well.
The news broadcast while I was driving along, and just thinking that it's a tragedy that people are losing lives, homes, possessions in these fires, and that there should be something that one could do about it technologically to make this less of a problem for people. It all flowed from there by thinking more carefully and by engaging with communities about what would really, really be useful.
So making electronics for an MRI scanner is actually really difficult. There's a lot of, it's quite a hostile environment for anything electronic. So I had to source components from all over the world, and I was just kind of a small guy bugging these pretty big companies. So an example is the magnetometer I used. I had to Skype a Swiss company for almost every day of a week, just bugging them each day, and also trying to get them to drop their price for me to get this sensor I needed. And luckily, they gave in finally.
I found that I was trying too much on a single prototype, so I had to cut short on the actual requirements of the design. So manufacturing with plastics, manufacturing with metals, I was not able to combine these two together. So that was again another bottleneck which we had to overcome. So that was adapted into the design, and we made the entire structure out of plastic.
To understand very carefully and very thoroughly what exactly the problems are, how these fires start, how they propagate, what it is that people fear about them, how people really lose lives and property in these fires, and what do communities that are facing this problem really want? In this case, we sat and we thought about it in our isolated ivory tower kind of way for a while, and we had our own ideas, but it took us far too long to engage with communities. And that was lost time. That was time that I regret not having gone into the communities, sat with people much earlier in the process and understood their needs and desires.
What we really would like to do is get this innovation out and to get it to the point where it's a cheap early diagnostic for cancer.
We would have tremendous potential. One, it'll be first of its kind to come out in the market for a specific clinical or a surgical requirement. Second, this is a disposable device, and potentially this can, because of the manufacturing technique that we are using, it can be used in most of the developing countries without really having to have a huge impact on the cost of the device.
I want to see a drastic reduction in the number of homes and lives lost. So to my mind, I will have succeeded when one can start seeing year on year that the statistics of loss of life and loss of property go down.
I guess, I want it to be used in clinical MRI. The limit of image clarity is now hampered by involuntary motion, so that's not even for children or the elderly who struggle with life still, it's for everyone. So it could technically be used in every MRI scan, hopefully one day.
Not to give up. I know in this project we had, we thought it was going to take about a month to complete the project after we'd finished our university degrees, and instead of taking a month, it took us 2 years. And in that 2 years, we had many failures, probably a lot more failures than we did success.
Make things. I think it's easy to talk to your friends about your great new idea and stuff, but whenever you make something, you realize there's 300 more problems that you have to actually deal with, and it's very easy to come up with the next big thing, but actually making it, you got to start somewhere.
I'm very passionate about serving people, and I think you can make a difference with whatever you're doing if you're really passionate about it.
The inspiration for inventions comes with the problems you see around you. We live in an imperfect world. There are plenty of problems, there are plenty of people who have difficulties that need resolving. You should be keeping your eyes open for those problems. Those problems represent opportunity for inventiveness, opportunity for innovation. It's very useful to be able to look at a problem, be able to decide whether it lies in your realm of expertise, and if it does, then look seriously at solving and put some real effort in.